these examples, we're going to use the method we learned with Venn diagrams to find the GCF and the LCM by using factor trees. We're going to use a website to assist in our calculations, and the address is right down here and in your lesson packet. So let's start with the directions. Highlight. Find the prime factorizations using factor trees for the following pairs of numbers and create the corresponding Venn diagram. Use the diagram to find the GCF and LCM. So let's start with 8 and 12, and we're going to go to this website. And if you go to that link, you'll need to press 2 for trees and user for problems, so you can enter your own numbers. So I'm going to enter 8 and 12. And it's going to prompt me to find factors for the factor trees. So I can think of any factor of 8 that I come up with. I'm going to use 2, and when I press enter, notice that it completed the other number. So you need to know that you would need to put 4 here if you're doing this by hand, but this is kind of handy that it does this for us. So notice all of these are circled because 2 is a prime number. So this factor tree is complete. Now, one factor of 12 is 4, 4 times 3, and 2 times 2. So now notice this Venn diagram has popped up, and we have 8 is 3 factors of 2, 12 is 2 factors of 2, and a factor of 3. Now I'm going to click and drag on the common factors. So I see they each have 2 factors of 2 in common. So I'm going to drag this 2 into the common factors, and notice 1 in each section disappeared because it's a common factor. Let's drag one more 2 in here. And now that's all the common factors. This 2 needs to just go into factors of 8, and this 3 needs to go into factors of 12. So we've completed the Venn diagram. Now it's asking us to find the GCF. Well, the GCF is the product of these two numbers. 2 times 2 is 4. And the LCM is the product of all the numbers in the chart right now. So 2 times 2 is 4, times 2 is 8, times 3 is 24. Now let's check our result, and it's correct. So in your lesson packet, you should put both of these trees and this diagram and your 2 results. We'll go back, and we're going to write that the GCF was 4 and the LCM was 24. Okay, and you can just include the trees in the diagram from the website. So now let's find 24 and 36. Let's find their GCF and LCM. So now I'm going to click New Problem, 24 and short memory, 36. And I'm going to start factoring. So 8 times 3, 4 times 2, and 2 times 2. So this is 24's prime factorization. 36, the first factor that comes to mind, it doesn't matter which you use, is 6. And 6 is 2 times 3. So now let's put what they have in common in the common factors. Well, I see 1, 3, and it's kindly removed those from both of the factorizations for me. I see a 2, and they each have one more 2 in common. Now, there's not a shared 2, so this 2 has to go into factors of 24, and this 3 goes into factors of 36. Okay. So the common factors, their product for the GCF is 2 times 2 times 3, which is 12. And now we also have another 2 and another 3. So 2 times 3 is 6, times this 12. Well, 12 times 6 is 72. If you don't know that off the top of your head, you can check on your calculator. And we check, and it's correct. So the GCF is 12, and the LCM is 72. GCF, 12, LCM, 72. Let's move to the next questions. So C, we have 24 and 30. Let's start a new problem with 24 and 30, and I'm going to start factoring. So there's 24's factor tree, or one of the factor trees of 24 that gives us the prime factorization, and there's 30. So I see in common they have one factor of 2 and one factor of 3. 24 has two factors of 2 in addition, and 30 has one factor of 5 in addition. So the GCF is the product of 2 and 3, which is 6, and the LCM is going to be 6. 2 times 2 is 4, times 5 is 20, so 6 times 20 is 120. Okay, that's multiplying 2 times 2 times 2 times 3 times 5. Let's check our result, and this is correct. So we have GCF of 6, LCM of 120. Okay, we have one more, 15 and 14. So 15 is 3 times 5, and 14 is 2 times 7. Notice they don't have any common factors besides 1. So I need to drag the 3 and the 5 into 15, and the 2 and the 7 into 14. Well, their only common factor, we didn't put 1 in here because 1's not considered prime, so that's not part of our tree. But when there's no common factors, that means the greatest common factor is 1. So it's not 0 because there's 0 factors, it's 1 because 1 is the identity of multiplication. Okay, and that's what this represents if we multiplied each of these by 1, not 0. Now the LCM, well, notice we just ended up multiplying 3 times 5 times 2 times 7. So it's basically the product of 15 and 14. I'm going to do that one on the calculator, and we get 210. So 210. Check, and we are correct. So the GCF is 1, the LCM is 210. Let's look at the next slide so we can start to look at some patterns. You may have noticed some already. Okay. So this is just a chart of all the numbers that we just looked at. We started with 8 and 12, 24 and 36, 24 and 30, etc. Here's the product of the numbers. Here's the GCF for these numbers. So basically this is just a chart filled in of the previous information. Here was the LCMs we found. Okay? So now here's what we want to look at. We're asked to find the product of the numbers divided by the GCF equals what? Well, this exact number is going to be different for each problem, but there's going to be a pattern or a relationship we can see here. So let's look at the product of the numbers divided by the GCF. Well, here we get 24. Well, notice that's the LCM. Here we get 72. Well, that's also the LCM. And it looks like this pattern holds for all of these. Okay? And this should make sense based on the Venn diagram, because the Venn diagram represents all of the factors of the two numbers, but the greatest common factor, we only put in one set of those prime factors. So if we divide the product by that, that would be the least common multiple. So product of the numbers divided by the GCF equals the LCM. And now we want the product of the numbers divided by the LCM. Well, looking here, we have 4, 12, 6, and 1. Notice this corresponds to the GCF, 4, 12, 6, and 1. So the product of the numbers divided by the LCM is the GCF. Okay? And this can be handy. I think I use this relationship more often here. If I know that two numbers, their GCF, I know they only have 2 in common. To find their LCM, which could be a little bit more tedious, I can just multiply the numbers and divide by the GCF.